Let's go through question 2 here. Now, question 2, you need to read quite a lot of code, quite some code to understand what is happening, identify the race condition, identify the critical section or sections, and then write a bit of code to deal with the critical section to remove the race condition from happening. So you are given these 3 files: employee record, age sorter, and employee processor. You're only allowed and only required to modify employee processor. Let's go through these files quickly. Employee record first. Now, this employee record basically it is a data structure. It's mentioned here. There is one constructor here, one constructor which takes in the file name. Basically, this is the file name of the CSV file, including the relative path. All right, and you don't have to understand the code here. Basically, a command here says everything. It reads the employee ID and the birth year from the CSV file and populate employees. Employees is this attribute. It's basically an array list. It's basically an array list here. And if you take a look at the CSV file, it basically consists of an employee ID and a birth year. That's it. You don't really have to open the CSV file or to understand how the employee records constructor works. All you need to know is that, well, you pass in the correct CSV file name and it will read the CSV file and populate this array list. All right, so even that is not really important. All these are hidden from view. What is important is you have to call this function, this method, which is a public method called getBirthYear. You pass in employee ID and it either returns -1 if there's no such employee, or it returns the birth year as an integer. That's it. This is the only public method available. Of course, the other public method is the constructor. Now, if you look at this data structure carefully, you realize something. Once the constructor is called and the employees array list is populated, is created and populated, right? There's no way anyone can modify employees. All right, there's only one so-called getter function, getBirthYear, and that's it. This is a inner class called employee, and that's it. There's no other public method, and there's no code which will modify employees. So technically speaking, even though employee record is not a thread-safe class, well, if there are multiple threads sharing the same instance of employee record, and these threads can only call getBirthYear, is there a risk that getBirthYear is going to return the wrong birth year of a particular employee ID? No, this is actually quite a safe class to use to be shared amongst multiple instances, multiple thread instances, which are actually calling getBirthYear at the same time. There's no way that employees is going to be corrupted. No one is modifying employees. Basically, everyone is reading by calling the getBirthYear function. All right, this is technically not a thread-safe class, but frankly speaking, there shouldn't be an issue with many threads sharing the same instance of employee record for this reason. So let's take a look at age sorter. Now, age sorter is where the main method is found. So you run age sorter, and here you create a new instance of the employee record using the CSV file. Like what I've said, you don't have to really understand the code here. You can just move on. 2 bucket objects or 2 array list objects are created. One is called bucket 0 and one is called bucket 1. And these are array lists of integer objects. You just want to insert the employee ID. Anyone 40 or below, put the ID here. Anyone above 40, add the ID here. Now, array list is not a thread-safe data structure. So it's very important that if there are multiple threads sharing the same bucket 0, they should not be calling add of bucket 0 at the same time. Okay, there will be the array list may be corrupted. Okay, because array list is not a thread safe class. So I create a pool, an executor service, and then here there's a for loop here which actually creates 50 threads, 50 EP instances, 50 employee processor instances. Okay, and then add them or submit them to the pool. Now there's this counter thing. Default value of counter is 1. After each iteration, I'll increase it by 5,000. What is this? Now, when the new employee processor instance is created, right, what is being passed in? The shared employee record data structure. Everyone, all these 50 threads are sharing the same employee record, so they can call the get birth here method. The shared array list bucket 0, the shared array list bucket 1. And this start and end counters are going to be different for each thread. So for the first thread, the start counter is 1, and the end counter, keep jumping, is 5,000. So the first thread is supposed to handle employee IDs 1 to 4999. Now, the second iteration, I'm creating a new employee processor and passing in the same employee record, bucket 0 and bucket 1 instance. But this time round, the start counter is 5,000 and the end counter is 10,000. So the second thread is supposed to handle employee IDs 5,000 to 9999. So there are 50 threads. Each thread is handling a different range of employee IDs, but they're all sharing the same employee record instance, bucket 0 and bucket 1 instance. So if you want me to draw it right, diagrammatically, it looks like this. So this is employee thread, the first one, employee thread, second one, employee thread, third one, and so on. There are actually 50 of them. All right, and they are all sharing the same instance of employee record. Which has one public method, get birth here. They are all sharing the same bucket 1 as well. Remember, this is an array list, not thread safe, which means that if these 3 threads are calling the add method of bucket 0 at the same time, there may be a problem because of a race condition. Similarly, all the threads are sharing bucket 1, which is also an array list of integers. You all should be able to see where the problem is now. The race condition is because all the threads are concurrently running and they are all concurrently calling the add method of bucket 0 and the add method of bucket 1, which is the race condition. Okay, so let's run the code. Before that, let's take a look at employee processor fast. So this is a runnable. No, this is not runnable. This is a thread itself. Okay, and there's a run method here. So there's a for loop, a big for loop which repeats 5,000 times, or rather 4,999 times. It will call the get birth year method and pass in the current ID. All right, and check if what is returned is -1. That's it. That means there's no such ID. Move on to the next iteration. On the other hand, if birth year is not -1, I'll calculate the age. And depending on the age, I'll either add it to bucket 0 or add it to bucket 1. All right, remember a lot of threads, specifically 50 threads, are doing this bucket 0.add or bucket 1.add concurrently. That is why there is an issue. All right, I'll quickly compile this. And run it quickly. Age sorter. And you realize that the number of employees in bucket 0 and bucket 1 won't be consistent because of this race problem, this race I'm looking at the wrong thing. Age sorter here. So what happens is in each sorter, right? um, line 44 and 45 will basically print out the number of employees, number of integers in bucket 0 and bucket 1. So the problem is every time you run it, you might get an inconsistent number. So the first time I ran it, bucket 0 contains 26405 numbers. Bucket 0 this time around contains 26403. And I'll expect the third run to also be quite inconsistent. Okay, 26400. There's a race condition here. Okay, because there are multiple threads, all of them are calling the add method of bucket 0 and bucket 1 at the same time. And array list is not thread safe. So where is the critical section? Employee processor. This is the critical section, this part here. Okay, I want to prevent multiple threads from calling bucket 0 or bucket 1.add at the same time. Some of you treat this whole thing as a critical section, this whole thing, including line 25. Okay, so one simple solution is just to synchronize the whole thing. Synchronized, I just need a common object, right? Which is shared by all the threads. A common object can be as simple as bucket 0. Because bucket 0 is being shared by all the threads. Visual Studio Code doesn't know how to format because of this. Okay, there it is. Synchronize bucket 0. Now it is very important that bucket 0 is the same object, okay, which regardless of which employee processor thread you're dealing with. All right, otherwise there will be a problem. Let's save this and run it, compile it and run it. Let me see if this is correct. Am I editing the correct class or not? Now, first thing you might notice is that this is super slow. Okay, let me run it again. 26401 for bucket 0. Let's see if it's the same. 26406. Oh, okay, I'm editing the wrong file. Let me as. Save as. Okay, where is it? Oh, okay, I'm re-editing the wrong file. Okay, I should be editing employee Q1, right? This one is Q2. This is the one. Save it quickly. Compile again. Run it. Now, this should take quite some time. Why? Because this statement, line 27, is very slow. If you take a look at employee record here, it has been purposely written, it's an array list here. Get birth here actually use sequential search. It's an ON operation to actually search for the particular employee. Now, you're not allowed to modify employee record, but it should be quite obvious to you that this is inefficient. All right, a better data structure would be, well, create a hash map. The key is the employee ID and the value is contributor and birth year or the employee object. Probably birth year. I mean, why do you need to store the employee object? Just a birth year would be good enough. But that's not the point here. You're not allowed to modify this. Well, even modifying, get birth year so that it performs binary search, since the employees are actually sorted by ID, right? It will be a huge improvement. But again, remember that's not the point. Okay, it's done. Let me run it again. So this is the actual correct number of employees in bucket 0 and the actual correct number of employees in bucket 1. The problem is it's very, very slow. Okay, let me see if the numbers tally. They should tally. My second run. Ooh. So this is a solution, but it's a lousy solution. Why? Because your critical section is unnecessarily big. Say consistent, huh? Don't care how many times you run it, it's going to be, these two numbers are going to be consistent because I've resolved the race condition. I've identified the critical section, but unfortunately, the critical section is unnecessarily big. Almost the whole run method is the critical section, almost because, well, in between the for loops, you are letting go of the token, all right, so that another thread can actually make use of it. Now, a better solution here is to shift the synchronized statement to here. Okay, let me reformat. It really doesn't work. Yeah. Now this looks better. Hmm. Okay. This is the critical section here. I mentioned just now that calling employee record get birth year should not cause a problem, even if this function or this method is being called concurrently by multiple threads, by 50 threads at the same time. There's no way the employee inside the employee record can be corrupted. And this is a very slow function. It's slowing down the whole thing. So this statement does not have to be protected. All you need to do is to protect these two. Bucket 0.add and bucket 1.add. And that's why I synchronize here. All right, let me save this and let me quickly compile and run it. It should give the same results in much lesser time. You still get 26415 and 33396. Huh? So this is a second version of the second correct answer. You get more points if you do this. This is still not the best answer. People who do this, you get 4.5 out of 5. All right, there's a better answer. Now, before talking about a better answer, right, some of you actually synchronize using this, and this is wrong. Okay, if you save this and run this, you'll get the race condition. It's not resolved yet. Okay, you see, numbers are wrong. The reason is because every instance of employee processor will have its own lock. And THIS here refers to the current instance. If you have 50 employee processor instances, there will be 50 locks. And this is not a shared lock. We need a lock which is being shared by all 50 threads. Instead of using this, some of you all did this lock. And then right at the top, you actually have this private re-entrant lock. Lock equals to new re-entrant lock. Some of you place this creation of the new re-entrant lock in the constructor. Now this is also wrong. All right, instead of using this, you use lock. But this again is not a shared lock. Every instance of EP has its own lock object. So this doesn't work. This doesn't resolve the race condition. Unless you use the lock factory to actually get lock. Is there a get lock? Let me check my lock factory again. I can't remember. Get lock, okay? And you use a common name here. Maybe question 2. This will work because each instance lock attribute, you'll be referring to the same re-entrant lock object. This will work. All right, because I've seen a few students doing this. This is fine, but this is not fine. Basically, there are 50 lock instances in this case. Okay, but in the first place, there really is no need to create a lock object. Just using bucket 0 or bucket 1 is good enough. They're already there. Just use the bucket 0's lock. Now, a better solution, perfect score, will be here, to use two locks. Okay, let me explain. I'm going to save this and let me compile it and run it. Oops, line 47, error. I think there's a bracket issue. This one. This one. Extra one. Right, let me shift this backwards. The problem is, it doesn't, VS Code doesn't know how to do this properly. Try Shift Tab, that works. Save it, compile again, run it. This is correct. It should produce the 26415 and 33396, correct. And this is the best solution. Now, notice that this critical section is being protected using bucket 0. This critical section is being protected using bucket 1. All right, they are different. There are two different locks. Lock 1 protects bucket 0. So if there can be many threads calling bucket 0.add, in order for any thread to do that, they must actually get this lock. Many threads may be calling bucket 1.add. In order to do that, they must get this lock. This will prevent, this actually maximizes liveness. What I'm trying to say is that, let's say if there are three threads trying to call add of bucket 0, while these three threads are vying for bucket 0's lock, a fourth thread trying to write to bucket 1 will not be affected. The fourth thread will try to get the lock for bucket 1. So it allows two independent threads. The first writing to bucket 0, the second writing to bucket 1. Why should you prevent thread A is actually writing to bucket 0 from doing its job, while thread B is trying to write to bucket 1? They're independent, right? So this is the best answer. It ensures best liveness and yet removes the race condition. So this is worth 5 upon 5. Yeah, that's it.